All right. Hi, everyone. I am Mike. I'm the first year PhD student from T-Lab. I will be your host for today and Chuyin.
My name is Chuyin, and I am a PhD student at T-Lab as well. And next, Lipeng.
I'm Lipeng. I'm the previous honor student, also in T Lab too. This is my first time to this journal club. And Vishaal.
Yeah, hi, I'm Vishaal. I'm also part of the same lab. I'm a master's student. Yeah.
All right. So the paper that we have read today is using cognitive psychology to understand GPT-3. Now, GPT-3 has, well, AI has been a very hot topic recently. And some people are debating whether the GPT have certain general intelligence and perhaps capable of certain cognitive tasks, much like the humans. So the author of this paper decided to essentially use the same cognitive experiment that had been used on humans on GPT-3 and see how it performs. Now, so the first approach that the author used is what they describe as a vignette approach. Essentially, they sort of give ChatGPT a little stories, and they ask, the ChatGPT's options or judgments based on the story provided. The same story have been provided to, of course, human participants, and these are written quite a long time ago. As it turns out, GPT have done pretty well in these vignette questions. They seems to be, no, GPT-3 seems to did pretty well in causal reasoning. They did well in card selection task. They seems to be able to incorporate the base rate in their judgment. They seem to have some issues with the conjunction judgment, so the Linda problem that have been used many times previously. They also failed the cognitive reflection. But all in all, they either made the correct inference in these tasks, or they made human-like mistakes. So they did pretty well, all things considered. But as the author suggested, there is some major problems. There are some major problems in this vignette approach. For example, because these vignettes have been written a long time ago and it's very well known, it's likely that the GPT training data include many of these vignettes already. So that wouldn't be a fair assessment of GPT's cognitive abilities because, well, they already know the answers. So another problem is that if you make small changes to the wording of these vignettes to make it just a little bit more unfamiliar for GPT, all of a sudden, GPT is no longer making correct inferences. They are not even making human responses in some cases. For example, in the Watson card selection task, if you rearrange the order of the card in the vignette, all of a sudden, ChatGPT make the wrong choice. So vignette approach, not so good. The author then decided to use what they called a task-based approach, where they procedurally generate these cognitive tasks based on certain principles to examine the cognitive ability and biases of GPT-3. They are mainly interested in four large categories. It's the decision making, deliberation / reinforcement learning, information searching, and causal reasoning. Right. So for the decision making, they essentially presented the GPT with a gamble task. They can choose between two gambles, and they want to know that whether the GPT-3 exhibits similar biases as human. For example, humans suffer, that's one way to put it. Humans suffer from framing biases. if you frame the gamble as a loss, people tend to make risk-averse decisions. When you are framing it as a gain, people are more willing to take risks, even though in this hypothetical gambling scenario, it's not that much of a difference. As it turns out, ChatGPT seems to exhibit 3 out of these 6 biases in total, including the framing bias I've just mentioned. So there's some differentiation between human performance and GPT performance, but so far, the GPT-3 is doing reasonably well. Then they move on to the information search with what they call a horizon test. So horizon test is sort of a series of 2-arm bandits tasks. Perhaps it's better if I give an example in this case. So imagine you are in the casino. You were asked to choose which slot machine you want to play, right? Now I come in and I tell you that I have used the slot machine A once, and I got a certain amount of money, and I used the slot machine B 3 times. Each time I got certain amount of cash. Now, given this information, you can choose 6 times, and you want to maximize your total profit in these 6 choices, right? The 6 choices given is the horizon, and the information that I'm telling you is sort of the previous sampling that I've made from both of these machines. Now, there are generally 2 ways to gather information. One is through what they call the random exploration. The other is called the directed exploration. Random exploration is essentially that you are looking at the information you are given and you are saying, well, sure, you have pulled this machine twice, but you may be lucky or unlucky in your result, and I'm going to just sample both of the options a bit more before I make the decision that which one has the higher rate of. The other option is the directed exploration, where you look at the previous information and say, okay, you pulled the machine A 1 times, you put the machine B 3 times. I'm going to try machine A bit more times just to see whether the first result is representative of the mean of the machine. Now, in this case, GPT-3 seems to be engaging in some form of random exploration, but not directed exploration. And furthermore, the random exploration that they are engaging in is independent from the horizon of the task. So let's say if you're only allowed to make 1 choices after given these information, then you're probably not going to do much exploration. If you're given a very long horizon, you're given a lot of chances to explore, then you may be engaging, when you're engaging in random exploration, we should see this back and forth between the 2 options. Because you are choosing 1 machine and suddenly you are getting bad result, you switch maybe to the other machine, and you switch back afterwards, given long enough time horizon. That's not what it's not what GPT-3 is doing. And this seems to be just random exploration without any specific strategy in mind. So that's quite peculiar and in some way inhuman. Furthermore, they are interested in the reinforcement learning. There are 2 types of reinforcement learning. One is model-based, one is model-free. I will give a simple example, even though it's not what the author have used in this paper. So if you imagine you go into a shop and you're buying a lottery ticket, you ask the owner, say, give me lottery A. But the owner of the shop made a mistake, and he gave you lottery B instead. You won a prize from that. Now, in a model-free reinforcement learning, you would say to yourself, well, I chose lottery A and I got a reward. So I should choose lottery A the next time I go in to buy the lottery tickets. In the model-based approach, you would tell yourself, well, I chose lottery A, sure, but I was given lottery B. And lottery B is the thing that gives me the reward. Therefore, next time when I go, I should not choose lottery A, I should choose lottery B. Now, the task they actually used in this test is a bit more complex. There are 2 stages, actually. But all in all, the GPT-3 seems to be using a model-based approach. So just like how real human learn from their experiences. The last experiment they run is about the causal reason of GPT-3. Essentially, they offered GPT-3 one model, let's call it common cause model, where element A is causing both element B and element C. And they ask, hey, what happens if you manipulate element B? Will it change element C? And then they ask GPT again, but with a different model called the causal chain model, where element B is causing element A, and element A is causing element C. And they ask, well, if you change the initial element B, well, how would it influence the element C at the end? GPT initially seems to be doing reasonably well for the common cause. But when they were given the causal chain model, they are not altering their responses. So essentially, they seem to be ignoring the causal model that the researchers have provided. And presumably, they are just randomly generating these responses based on the text prompt. So they are having a lot of difficulty in these causal reasoning and incorporating causal informations. The last thing that they did is to conduct a robustness check for the GPT-3. The point is that because as mentioned before, small changes in the text prompt may lead to a very different response in GPT-3. So they varied a few different factors. For example, they gave different cover stories. They changed the unit of the currency. They changed how the question is asked, so on and so forth. It seems in most cases doesn't make a major differences. There are some improvement in some cases, but it doesn't change the core result that they have found. One interesting thing is that in the Horizon task, the series of one-armed bandits, right? Instead of say a casino, they asked in the cover story of an investment firm. And in that cover story, it seems GPT is a lot more risk averse than in the casino example. So that's quite interesting. In the end, the author concludes that while it's very peculiar, I guess, for a large language model to suddenly acquire these cognitive capabilities, GPT-3 does seem to possess at least some abilities, and rather than just simply parroting like human language, I guess, habits. So yeah, that's the end of the paper. Have I missed anything? Do you see anything I should clarify more?
No, I think. Thank you very much, Mike. That's really good.
Yeah.
Yeah.
I think I can start off the first question actually. This is more of like a fundamental question because I mean, in terms of computational methods and everything, it's not really I mean, I don't know too much about it yet. But I think the underlying question that I had, like while reading through this paper, is why, like how GPT-3 operates, right? Was it even like necessary, I guess, to assess its function using a cognitive psychology and a range of cognitive psychology tests rather than just going into GPT itself and just deriving and deducing how it works based on how it is actually programmed or made to work, you know? Because at the end of the day, it's a large language model, right? It's running on programs and algorithms, which is upskilled and everything. So I guess beyond just drawing comparisons between how GPT works and how human learning works or decision making works. I mean, yeah, I can see that, being I can see that comparison being drawn, but um, in terms of the like one of the points is to understand or demystify how large language models solve reasoning problems, right? To understand the complexity of their behavior. But couldn't you deduce that from just dissecting how it is made, programmed, constructed? I don't know. It's just a thought. It's not really a critique, it's just like a thought for myself. But yeah, I just wanted to share that as well. So yeah, if you guys have any thoughts about that. Well,
I mean, correct me if I'm wrong, but because how many parameters there are let's say GPT-3, I think they also mentioned there are like 175 billion parameters.
something like that, yeah.
I'm like, how long would it take if, we have a team of 100 scientists, we're just looking at the parameter relationships?
Yeah, but I'm pretty sure the engineers of GPT-3 have like a log, right? Of, of
But
what are the notable upgrades or improvements or algorithms they're adding, Like they probably won't record like a minor algorithm, but if it's like a big notable change, you probably would take note of that and say, oh yeah, we made this improvement and here's what we added. But yeah, I don't know.
hmm,
I think to me, if I understand your question correctly,
Yeah.
I have another analogy is that especially for our lab consciousness, if we want to characterize if we imagine this as a mountain, so the pathway you mentioned is like from the bottom of mountain and then we go to the top, right? But
Yeah.
but for this study, I think it is from the phenomenology and then like a helicopter to the top of the mountain, and then to deduce the black box of GPT-3. I think this is what I'm thinking about this. It is very difficult to really understand the algorithm of such a large amount of this how do you call that, neuron or parameter? Yes, it is a bit difficult, but if from phenomenology we maybe can deduce something that very similar to human, and then
Yeah.
yes.
Okay.
And what I think what Vishaal just explained can be better called bionic, a bionic way. And I'm not saying it's impossible, but so far it's applying to simpler situations, not human brains, and it's a bit to me, or maybe I'm wrong, but to me it sounds very complex for a human brain to build a program to algorithm based on the bionic idea. Yeah.
Right.
And it reminded me about another thing is that if we I assume that if I can compute a single cell or atom and then characterize or code all its function into computer, then can I generate or through a very large amount of iteration can I create a creature in computer?
Yeah.
Is that
So
possible? Right.
now it can only be a thought experiment. We cannot achieve that, but maybe in the future we can achieve that and test it actually. Yeah.
Yeah, I think the Vishaal's idea is very interesting.
I'm
And
kind oh,
please.
thank you. I'm kind of curious what do we think on like how does this language model acquire this capabilities? Because as far as I understand, the transformer is essentially a more complicated text prediction, right? You are predicting the next word, and you made some kind of a separate, well, not separate, but like there's a judgment AI that you made that collect human response, you train on human response previously, and you are using it to assess your predictions essentially. That's how I understand it. So how does these decision-making biases or abilities arise in the first place? How does GPT learn? In the context of these cognitive experiments.
You mean learning the situation or learning the human bias?
Yeah, I mean, I'm sorry, I'm talking about learning the human bias. Yes.
Okay.
How do they acquire it in the first?
What, human biases, you said?
Yeah.
I mean, I don't know the exact theory behind it, but I always thought human biases I mean, part of the nurture process rather than nature, right? You grow up forming schemas of the world around you, and you just have precognitions of pre-assumptions of how things work and everything. I don't know if that is considered biases or not, but yeah, no idea. Yeah, I'm rusty in my cognitive psych.
I also have a follow-up comment with your question. I also have same question because this large language model is trained to like predict the next word one by one, and then with the possibility of some kind of possibility thing, and then it generate human bias. But what interests me most is that some of the bias is manifested by GPT-3 and some are not. I'm curious why.
To me, I think this paper, in this paper, all the tasks cannot avoid, say, being already included in the training materials of GPT-3. So maybe the training materials are very large and cover a lot of various topics. So there may be some part of materials who mention these scenarios and say, yeah, human will have such a bias. And in some other training materials, they might say, yeah, we have such a scenario, but the real answer is blah, blah, blah. So in the training materials, both human bias and correct answers should be mentioned. And then what GPT models will respond might be based on the balance between those two answers in the training materials. That's what I think so far. Yeah. Unless, if I can add something on, I think future studies must try some original situations, some original questions based on those ideas to test. They cannot keep employing existing scenarios because they should have been included in the training materials. And what GPT models respond will reflect the balance in the training materials. Yeah.
But I guess in this case, just speaking from the author's perspective, wouldn't they argue that since they have procedurally, generated all these tasks, even though the underlying logic perhaps is similar to some of the things that GPT have seen before in the training material, wouldn't it still be quite novel for GPT in that sense, or do you think it doesn't make a difference?
You mean changing some small, like changing dollars to euros, something like that?
Changing color, changing, say, cover stories, or changing the options, which, let's say, originally it's $100, now it's $1,000, right? Changing that sort of information.
That kind of modifications, I will say, we cannot be sure that no one has done it yet. Like maybe some people from United States say dollar, and maybe some people from Britain will change it to pounds. we don't know whether or not it has happened on social media or so.
Sure.
Yeah. So those kind of small changes, I guess we cannot rule out the possibility that some random people have done it before.
I was thinking more along the lines of perhaps, our language capture a part, like how, something about how we think. Because, well, if you think about it, language is one of the main purposes communicate the thoughts between us, right? We're currently having a discussion where we're using spoken language. That's the entire point. And by learning the language structure and by making these probabilistic prediction of our language, GPT was able to also capture some sort of human biases in the cognition. But of course, not all human thinking can be found in languages. So at the end of the day, we found some biases that they have learned successfully from human language, or others they have no idea, like causal reason. They don't know what it is. Is it?
This is a comment, right?
Yes, it's a comment.
Yeah.
Let's move on.
Yeah, I can't really answer or judge you. Yeah, so it's okay. I have some interesting things to provide maybe. While reading the paper, I just copied some of the questions into GPT-4, and GPT-4 actually gives opposite answers, different answers.
Wait, ready? Can we have a look?
Yeah.
I'm not sure if the audience can see this, but maybe we will.
You are recording, right? I'm sharing screen, and this should be recorded. Yeah.
Yeah. I'm not sure how gallery review work with this, but we'll be fine, I'm sure.
Yeah, I think yeah, the exact same one is this CRT question. I just copied the text, and GPT gives 0.05 with some analysis code. So it transforms this situation into computation code. And for this Linda question, I can't do much. So I take a screenshot. This is a screenshot. And GPT pointed out this is the Linda problem, and it's most like this option 1 is most likely to be true. So there's no bias. So it means GPT knows this problem, like us, a psychology student, who we see this scenario and we immediately know, yeah, this is a Linda problem. We have learned in bachelor degree or so, and then we say, yeah, the option 1 is the most likely. Something later, and this horizon, I don't know how to say that, but again, GPT transformed it into some calculation code. So it probably means GPT-4 it's more rational. I'm not sure, but this is some interesting fact that I can provide to the audience. Yeah.
Oh, that's very interesting because it's doing math instead of, making word prediction in this case, it would seem, right?
Yes.
I have a comment for this because the previous this paper they use GPT-3, and then I use Connect Paper, this website, to see is there any paper related to this one, and then I can see that some scholar proposed something that call sorry, wait a minute, let me check.
You want to share your screen?
Wait, I don't need to share my screen. It's called chain of thought. So which means that if we add one of the chain of thought to GPT-3, then it will perform as great as GPT-4, I think. This is what they proposed. And the chain of thought is that, for example, okay, I can share my screen.
Okay, I will stop sharing. Yeah. Let me guess. It's like you are chatting with a person.
Okay, you see that? I can zoom in. So instead of directly telling them the answer is 11, they will add a sentence, facilitate GPT, or as a template for GPT to think about this question. This is COT, like chain of thought.
Okay.
And then there's another paper, which is, well, I think it is over 4,000 citation, saying that large language model are zero-shot reasoner, which is in this case. Just, I think it is the same as GPT-4, like without this kind of chain of thought prompting, the GPT-4 will have their internal process of chain of thought.
Sorry, you mean GPT-3?
No, GPT-4. GPT-4 is this. I think GPT-3 don't have internal chain of thought, which leads to poor result in cognitive experiment.
So for GPT-3, you must tell it the chain of thought.
Yes. If I want to improve the performance of GPT-3, I think add this sentence.
But for GPT-4, it has built-in chain of thought.
I assume that.
Okay, so as long as you say, let's think step by step, and GPT-4 is able to provide this chain of thought.
Yes.
Like,
yeah. Well,
that's a big improvement. Yeah.
All right. So this paper, I found it by connected paper, and then this is large language model, a zero-shot reasoner. Well cited. Oh, it is 1,200. It is not for 4,000.
Well, it simply means that field is very popular. A lot of people are working on that.
True. And then for this paper is Marcel Binz. They have published another paper, not yet published, but they have another work. You can search it online. So it is also a work about large language model.
Okay.
So the idea here is that I think the chain of thought is very key. It's very important to large language model, which is very sensitive to the prompt we gave them, right?
Yes, right.
But why is the chain of, well, I mean, obviously the chain of thought empirically it's necessary, but mechanistically, why can why would it be necessary for GPT to be reliant on chain of thought rather than, is it because that there are some hidden reasoning that's involved in the initial questions that have to be broken down into small pieces for them to make individual judgment and understand? Is that the
for
case?
now, I don't know. I don't know. I didn't read that paper very.
Imagine when you are doing a CRT test, if you are asked to give an intuitive answer, you are more likely to make a mistake. But if you are asked to give the equations, to do the calculation step by step, I don't think you will make a mistake.
Okay.
That's also true for human. We can imagine that.
But it's not. It's a language prediction, right? It's predicting what's the next word, and does that tell us something about our own language?
Well,
that's a great question. Yeah.
I don't know how to answer
I don't know.
that. Sorry.
Yeah, that's very interesting because large language model is like generating a word after another, and then if we provide a channel of thought, why does it change their answer or improve their performance?
I will guess there must be training materials that contain such chain of thought. Yeah.
I see what you mean.
Especially for the classical situations, people have analyzed it, written about it many times. So I will say the information is there, but it's a choice of the language model whether or not to use it. Yeah. Based on
I guess that leads us to perhaps the central conclusion of the authors, whether GPT-3 is just, what they call a stochastic parrot. I think that's the wording. So do we think that the GPT actually have some kind of, more generalized cognitive capability, or they have seen the material in some way before, and they are just once again mimicking?
Objectively, I would say no. It will only perform as to the extent it is programmed to. It's still a combination of algorithms and
Yeah, but
Yeah.
aren't we just a combination of cells and neurons as well?
Yeah, I guess.
Yeah.
But I don't know. It's hard to say. We can be we can be a combination of cells and neurons, but each personality type is structured differently, each person works different. But that becomes a lot more philosophical. So yeah, I'd say. But yeah. But maybe I'm just weighing my opinion based on my own personal bias. GPT is not an AGI yet, an artificial general intelligence yet. It's just a large language model. It's not even an AI. So, so yeah. I mean, it is. I don't know. I don't know what's the terminology exactly, but yeah. So, but yeah, that's my stance. Yeah.
To me, I don't want to rule out the possibility that we can train. We can using the methodology of training a large language model to have something that can perform exactly the same as humans all the time. I don't want to say it's impossible. It's possible, maybe in the future. But so far, based on current evidence, current models, GPT-3 and even GPT-4, I will agree with Vishaal. I will prefer that it's still just a reflection of training materials. It's not human mind. Yeah.
Okay. I also have an open attitude to this question because I learned something that called emergence. So where, for example, the activity of a single ant is more like random, but for a group of ant, like colony of ant, we can see that they can create some internal division of labor, and that internal division of labor is like emergence at sudden. Some scientists are trying to find out why, and I also assume in our like neuron or the parameter for a large language model, there could be some kind of consciousness or cognitive emergence at this with the number of parameter increase. So I will hold an open attitude to this question.
It's
Well,
sorry, back you.
I would just quickly there you guys already said my opinion essentially as well. I'm a bit more optimistic about the capabilities. I think it does represent something interesting in this case. But yeah, there's a long way to go and many things to see.
And at the end, I want to add a question or repeat a question that mentioned by the authors. And they mentioned in their discussion section whether or not we should treat GPT model as a single participant or many participants. I think this is a very good question to consider. I have never seen that question before. Yeah, when comparing GPT models with human participants, I feel it's more, yeah, it probably should be treated as the average of many human participants. Yeah.
If that's the case, can we, or the next direction of psychology study, can we combine meta-analysis with GPT analysis?
Yeah, I think we should do that. Maybe compare the results from GPT models and results from
meta-analysis.
Yeah, this is something important to think about. Yeah. Okay.
All right. Are there any other questions that we want to discuss?
No.
All right. Well, thanks for coming, everyone. This is us for today.
Yeah. Thank you, Mike.
Bye. Thank you.
Thank you.